Hello, everyone. I'm Laura Greiner, your host for today's Swine It podcast. And with me today, I have Dr. Tom Crenshaw, who is a professor at the University of Wisconsin. Tom, how are you today?
Doing great. We have a little bit of sunshine out today. For those of you that may be in other climates, it would be nice if it was a lot warmer, but great to be here.
Well, you're certainly doing better than we are. We have sleet and snow this afternoon, so I'll take the sunshine any day.
Right.
Well, Tom, before we really get started in our topic today, maybe it'd be good to help our audience who may not be familiar with you to give them a little bit more background.
Okay, so Tom Crenshaw, as Laura mentioned, at University of Wisconsin in Madison in the swine nutrition area. I've been here since 1980, and if any of you want to do the math, it dates me quite a bit. So I'm getting a little bit long in tooth is the way I describe it to some people. But did my graduate work at Nebraska and then came to Wisconsin in kind of a unique position here to help establish the Swine Research and Teaching Center. And I'd say that's, off and going. I was up to the unit actually this morning. My voice may be a little bit graggly because of weighing pigs this morning, but anyhow, that facility is running great. We have a lot of different people involved in research projects here, but in my position at Wisconsin, I've had the opportunity to interface with a lot of what we might call production ag research, but also with people that are in other departments that use the pig as a model. And that's allowed me to bring, some of their into the animal agricultural area by, understanding what they're trying to do with biomedical models of pigs. And I think that's been quite a benefit to our program here. So it's been a kind of a fun opportunity for me. My background in research more directly into the swine area has probably been over the long term with calcium and phosphorus in bone development. I think people that might know me, that might be where they would kind of go to first. But we've certainly had opportunities to be involved in other research projects over my career. Worked a lot with a guy here, 𝘵𝘩𝘆𝘵, that some people may know that has done a lot with amino acids. And Ben and I have worked together for years. I had a lot of great students coming through the program and working then in a lot of different areas. But just wanted to kind of acknowledge Ben early in the conversation here.
Yeah, wonderful. Yeah, I think that's a great introduction. And certainly that's how I would recognize you as well as my go-to bone expert. And we were visiting a little bit ahead of time here on some recent work that you're doing. And I think that would be really a good place to start. We certainly continue to hear of some challenges in finishing associated with lameness, and certainly animal survivability, sow longevity are always top on people's lists. And so maybe let's start there with some of the new technology or the new ways that you're trying to help identify status on a sow farm, for example, of where we're at in terms of calcium and phosphorus, and how are we meeting those requirements?
Okay, so so recently one of my grad students, 𝘥𝘰𝘭𝘷𝘦, has completed a project in which it was actually started with an interest in the uterine prolapse, and we did some stuff looking at whether sows might develop kind of a milk fever type response. Being in Wisconsin as a dairy state, we've been exposed a lot to the dairy industry and how they've dealt with milk fever responses. And I've often been asked the question, do sows develop milk fever? And I would have to say that we've set up experiments where we've actually tried to induce those kind of conditions in the sows, and we've never been able to document a milk fever hypocalcemic response in the sow. And we've tried to do that from a research standpoint. Can we create conditions that would lead to that? And so 𝘥𝘰𝘭𝘷𝘦 started off with me on that project, and the whole concern at that point, and still a concern, would be the uterine prolapses, pelvic organ prolapses. But we were in the database not able to show any drop in serum calcium concentrations, even in diets that we over supplemented with calcium. And we know from dairy cows, the oversupplementation of calcium during the transition period, the dry period, would actually increase the incidence of milk fever. So oversupplementation in the dairy cow has been kind of documented to be a problem. We did that with sows, and we fed sows high levels of calcium and phosphorus, probably above a little bit before the industry would typically even feed the sows. And there was no evidence that even under those diets versus control diets that the sows ever dropped in serum calcium. We had sows that we had inserted venous catheters at frequent 15-minute interval blood samples at multiple time points throughout the day, and at the end of gestation, right the first few days of parturition, and even out to day 18 of lactation, we could not show any drop in serum calcium. But what we did see in the sows that were not expected was a drop in serum phosphorus. And that decrease in serum phosphorus kind of led us to the question of what's the phosphorus requirement of the sow? So with Mariola, we deviated slightly and went into a little bit different direction with her PhD project. And she did a very nice job with very meticulous collections. And we collected urine excreted. We did 24-hour urine excretion, collected sows that were fed. I think we had 6 different dietary phosphorus levels, and determined from the 24-hour urine excretion the phosphorus requirements of the sows. With the idea, I think she's certainly right with the set point, the physiological set point. Trying to measure blood samples is not a very good prediction of phosphorus requirements. Very difficult, especially in a university setting with limited number of animals, but I think even a major challenge, even in commercial operations, is to say, what's the phosphorus requirement? Are we feeding an adequate level or not? If you tried to base that on reproductive performance, litter size, even weaning weights of the pigs, I don't think would be a very good predictor or very sensitive predictor of phosphorus requirements and phosphorus status. Because as all of you know, and the listeners now would know as well, is there's a lot of factors that affect pig numbers and weaning weights and survival of the pig. So that's just a variable trait. But if you think about how calcium and phosphorus is handled in the body, if the phosphorus is absorbed, one of the major routes that is used to get rid of the excess phosphorus would be through the kidneys and renal excretion of phosphorus. So give some credit to Mariola there for thinking about the homeostatic mechanisms that are involved in regulation of calcium and phosphorus. And so we set out to collect the 24-hour excretion, then had this idea that if we did grab samples, could we use a grab sample to predict the 24-hour excretion? And a lot of analysis now of different calcium, phosphorus, creatinine, different minerals that would be excreted in the urine. And I had this great idea that maybe we could use potassium as a way of correcting for dilution. And so we tried several different things, but Mariola now is very meticulous with her work and very capable with statistical handling of that. And what we found and finally arrived at is that with a grab sample, we could predict the phosphorus status by looking at the calcium to phosphorus ratio in the urine. And as far as we know, that it had been applied. There's a couple of other cases in the literature where people have used calcium to phosphorus ratio in growing pigs. To our knowledge, this is kind of the first place it's been used with sows. Now, I'm not trying to discredit anybody, but I think that's, we cannot find that in the literature. If somebody out there has information on it, we would be open to that. But with the data set, she was able to establish requirements of sows, kind of a minimum requirement. And we usually think about requirements as, here's a single value that you try to say is adequate for the animal. There's certainly a lot of variation in animals, but with what we've done with the urine calcium to phosphorus ratio is actually establish ranges. So using that ratio, we bracketed into 3 different categories. We say this category would reflect animals that would be deficient in phosphorus. and that's when the ratio of calcium to phosphorus is high. And then there's a bracket that in this middle range, based on the evidence that we have, we would say the animal is adequate in calcium and phosphorus. And then there's a third range that these animals are, the calcium to phosphorus ratio would reflect the animals are being fed excessive levels of phosphorus. Now, we all know that there's concern about phosphorus and environmental pollution. And if you look at what I typically see that might be industry standards, if anything, at least in the US, we're making a mistake by overfeeding phosphorus, whether that's in terms of inorganic phosphorus or phytate supplements that might be provided more phosphorus released to the animal than what they would actually need. So that means that there's, that concern for the excessive phosphorus. So what we would kind of challenge the industry we've thought about, but really have just not done on a large scale basis yet, would be, could we go into larger herds of sows, do a quick grab sample of urine? And there's methods now, as I mentioned earlier, to use. Some of your colleagues at Iowa State have worked out, techniques to do grab samples of urine from sows on a large scale basis, measure the urine calcium to phosphorus ratio in that grab sample, and from that ratio predict the status of the entire herd. And then from the nutrition perspective, you could use that information to alter the diets, tweak the diets to fine tune the requirement of the animal based on that assessment of the profile. It'd be, in one sense, kind of like, well, grab a blood sample and let's measure something in the blood and make an adjustment for that. Well, we all know that, blood samples of calcium and phosphorus are not very good predictors, but the urine sample then would allow that to occur and maybe a better assessment of the herd based on the urine output rather than a blood sample. It's probably easier to collect the urine sample than it is the blood sample actually from the sows. So that's kind of an area that we've just finished up some of the work that we can do in a university setting in a more intense basis, but at the same time, we've tried to keep contact with enough people that are maybe in your listening audience or that would be out there, would challenge us with ideas of how can we put this into a practical endpoint and a practical use.
Yeah, and I think that was really kind of my next question was, what would be that next step if somebody in the industry wanted to go out and look at the status of their herd, those ratios that you're defining where we're saying if the ratio is high or low and outside of a range, do we think that range is pretty fixed across all sows, or is this going to be well, we might have to see if this population has a different ratio range that's acceptable versus another population?
Yeah, I mean, I don't know that that's certainly a question, and we've asked that question, and I think we even addressed some of those limitations of the study, maybe in the paper that's published on that. But genetic differences, breed differences that might be there, health status differences, how would that affect calcium and phosphorus excretion by the kidneys? I think it will kind of hold. Now, that's optimism and speculation on my part. Would like for that ratio, and we don't know until we do that on a kind of a wider spread scale basis. I don't know that I mentioned this earlier, and maybe this is not the right thing to say over a podcast, but I grew up in Tennessee, and so we talk about bootlegging. So this experiment was kind of a bootlegged research experiment that we did, so that we've not really had the funding to go out and certainly do it on a large scale. That would be an interesting project to work on, and maybe other people, I'm far enough along in my program, if I can give ideas away to other people and they do the research and share the information back with me, that would be great. I'm not here trying to generate research funds or something like that, but it's an area of interest, and I see a lot of practical application for this. I think it has a lot of potential to be a way that we can screen and monitor herds, and maybe that has to be adjusted within a herd. But it certainly would give a kind of a guideline for the nutritionist to fine tune the diets, especially if they're tend to be on the side of over formulating the diet. It might give them confidence in being able to back off a little bit on the excess phosphorus that might be going into the diet.
Yeah, and certainly this is an easy assay, if you will, to run. It's fairly low cost, we would assume. So that's beneficial for our herds. And I do want to reemphasize, I think you hit the nail on the head, that this is really intended, if you're going to even start this process, to look at healthy animals. Certainly we know sick animals, the blood calcium levels are going to be shifting, especially if they're not eating. And so you definitely want to make sure that people are looking at this appropriately.
Right, and I think there's certainly a lot of management issues with the animals. If you're going through an acute break with something, that would not be the time to try to assess the diet status or maybe make major changes even in the diet. But certainly working with the veterinarians and the nutritionists, I always want to encourage those two populations of people. I think we've gotten in the industry a lot better at that, but I know there can still be issues there. Work together with each other. If there's a health status problem, try to resolve that best way you can. And I've made comments now to veterinarians before, and I think different people would agree with this. We cannot solve all the problems with nutrition, and certainly throwing more nutrients in the diet is not going to solve the problem. So we've got to work together to begin to solve those problems rather than being kind of a battle or a controversial issue with each other. So work together on those problems, certainly.
Sure. No, I think that's really good. So I found that was actually really interesting and something that I think should be followed up with, and certainly encourage our audience to think about ways that they can take that information and figure out how they can assess it in the field. I also want to kind of switch gears a little bit on you as we're talking about field application and the research that you're doing. The other thing that you're currently doing a lot of work on is the follow-up, like some of us, on COVID and some of the processes that we use during the plant shutdowns to mitigate, the growth of our pigs. And so maybe you could allude a little bit more on what you're doing currently there as a follow-up to some of that early work.
Sure. And, I should certainly, with you, hosting this, I should acknowledge my colleagues at Iowa State that, I've always tried to give credit that even before the plant shut down in 2020, I think you had research projects, Nick and John Patience had research projects going on how you could slow down growth. And I got calls and some questions with how would you deal with calcium phosphorus ratios using calcium chloride. So I'm not trying to pick on what you've done, but that's a product that was out there. And over my research career, I've always had an interest in acid-base balance, cation-anion balance. And I would have to say, from a practical standpoint, never came up with anything that, here's where you can really apply that in pig production. Other animals, go back to the dairy cow and acidifying the diet with a decad balance and trying to affect bone mobilization. It's certainly an industry, and the dairy industries have adopted and used that. So I've always been aware of that, but never came up with a positive, well, this is what you can do to really help the swine industry. But you got the phone call, we're talking about calcium phosphorus ratios and how to kind of deal with the diet. And I thought, this was my comment to the person on the other end of the phone is, that's the wrong approach. They should be using ammonium chloride rather than calcium chloride. And a lot of the basis for ammonium chloride goes back to work that was done with humans in the 1940s and 50s. And keeping up with, acid-base balance and cation-anion balance, and read and was aware of those papers. So we started out with some experiments. First, we actually put ammonium chloride in the water, thinking if there was a shutdown, a stop shipment order, could we stop the growth with ammonium chloride in the water? So we did that. At our research facility, we were actually we did not have a place to ship pigs. We were, about a 200 sow herd. Okay, so it's not nearly the numbers that people in the industry were faced with, but we had the same problem. We had nowhere to ship pigs. So we actually put pigs in 2 of our finishing rooms. We cut into the water line in about a 24-hour turnaround with our crew, which I gotta give them credit. They were able to be innovative and come up with ways that we could medicate the water, not through a water medicator. The concentration doesn't work quite right for that. But we cut into the line, had a tank, just a water tank that we put in line, added the ammonium chloride to that. And over the first week, we had growth rate that was reduced by 90%, a 90% reduction in growth. We know we ran into some problems. We had the large animal veterinarian involved with us and kind of given us permission. We have to have in university settings, protocols and procedures to do that. And that's, we were able to jump in and do that with their support. And we stopped growth, but there was a concern about ulcers that we ran into. And we don't know if it was related to maybe the stomachs were just not full, and that was contributing to the ulcer problem. And with some diagnosis of the herd, we actually found that there were pigs in other parts of the building that also had some ulcer problems. So we're not sure that it's tied directly to the ammonium chloride. In multiple experiments that we've done since then, we've really not had an ulcer problem that's a predominant issue or major concern. But we stopped the water treatment because of that. And we went then to some feed medication, and we've kind of titrated the dose out with ammonium chloride that we can use in the feed. And I would say there's a couple of tricks to this formulation. And certainly, again, willing to share those, and if other people have ideas on it, but goes back to some early work that we had done with purified diets with ammonium chloride and looking at sodium potassium chloride ratios and the chloride balance. We have done research in that area in the past, but we found that the potassium to chloride ratio is a critical component of this. So if there's excess chloride, the body may need potassium to help balance that electrolyte. That seemed to be, in our early work, seemed to be more important than sodium and chloride. So what we did with the diets, that we tried to minimize the amount of ammonium chloride that we would put in the diet. And we reduced the nutrients in the diet. So we reduced the cost of, if you're feeding a pig during some kind of a holding period, we reduced lysine and we reduced phosphorus in the diet to try to cut down the cost of the diet during that time period. And by doing that, we also decreased the amount of soybean meal, if we're using soybean meal as the protein source, which is the main source of potassium. So we've dropped the potassium concentration in the diet, which, as we've titrated in different doses, that's allowed us to provide less ammonium chloride if we can keep a potassium to chloride ratio at a certain level in the diet. And potassium is certainly required by the animal for lean deposition. And if the animals do not have potassium in the diet, they don't grow. So is it acid-base balance, or is it a depletion of potassium? And so that's given us a tool now that we can alter the electrolyte balance in the animal and change the growth of the animal. We have some indications. We're still working on lab analysis where we've done a lot of collections on some of these pigs in these intense studies. But we've some indication that the potassium chloride ratio is really a major driver in this. And we can actually feed diets with ammonium chloride. You say, well, it's the taste. I typically make my students taste of the diets of the ingredients. Now, some drugs I would not have them do that, but they tasted the feed. And ammonium chloride does definitely have a taste. It's used in beef cattle diets for urinary calculi, can be used in other diets. It's now, to my knowledge, it's not approved by AAFCO for use in pigs. There's no AAFCO claim on that. And we did have some discussion about that. From a research standpoint, we can do it. My understanding, if the feed is not being sold commercially, that could still be added in. And some of the guys in the listening audience will know more about this than I do, but have checked into those areas. But it is approved for use for other animals. But the ammonium chloride has I don't know how to describe the taste, a very tart, I would not describe it as bitter, but you definitely know that even 2% addition in the diet, you can taste in the whole feed and you can taste it. Is it a taste palatability thing? So we've addressed that. It said, well, if we put ammonium chloride in the diet and no ammonium chloride, and we gave the pigs a choice between two feeders, they would certainly select the feed without ammonium chloride. And we had actually done that with gestating sows, lactating sows years ago. So we knew that would really not be a good experiment. So we decided we could put potassium on top of the ammonium chloride, correct the potassium to chloride ratio, and if that happened, then the pigs should continue to grow, even though there's ammonium chloride in the diet. And that actually works. So we rescued the pig with adding potassium back into the diet. And so we have some evidence that that ratio is kind of an important feature. The potassium to chloride ratio is an important feature in controlling the growth rate of the pigs. So we've actually now, this summer, we're presented the National Animal Science meetings, work that we've done with pigs from the end of nursery all the way to market at different weights. So we held pigs for 4 weeks at 25, 50, and 75 kilograms. So we stopped the growth. Don't remember the numbers exactly, but it was about an 80% reduction in growth in those different weight ranges. And then by market weight, we followed the pigs, put them back on a recovery diet, and let them grow back. And this was just the standard diet that we would routinely feed to those pigs. And the pigs, when they were actually marketed at that final point, I think our final weight point was 130 kilograms that we had targeted. So when they got to that weight, we shipped the pigs, and they were only 2 weeks behind. So they had compensated for that 4-week lag in growth. And we're working with a couple of faculty colleagues in Ag and Applied Econ department, 𝘱𝘵𝘁 and Andrew Stevens. They're taking the data from that experiment and developing an economic deterministic model. So can we predict the cost of this? So the recovery and how fast the pigs recover from an economic standpoint may be as important as the idea that can we actually stop the pigs from growing. So we stop the pigs from growing is still important, then that we're able to take those pigs and market those pigs whenever we're free then to ship the pigs for whatever reason we're holding the pig. And so that's kind of what we're trying to do now with the model we're working on. We have a data set now that we can work on the economic model. Those guys are certainly the experts for that. We can hold the pigs, and then we're trying to still answer questions about the diet and can we stimulate during that recovery period, can we stimulate lean deposition rather than fat deposition? And we're doing that with DEXA scans of pigs as well as more the standard carcass data traits that you would measure from the slaughter plants. And then the big concern, or that you and I had mentioned earlier, is what happens to the bone. You know, have we affected bone and mineral deposition? And with our DEXA scans, we get a more quantitative measure of the mineral deposition in the pigs. We can detect differences with what we've seen so far. We don't know, we've not seen any evidence that we've compromised the pig enough that it would not be able to make it to market weight. We know we have some differences in the whole body bone mineral content of the pig, but we have not seen problem with lameness in any of the pigs that we've worked with there.
Good. Yeah, you actually brought up a couple of interesting points and some that I think we could probably do another whole podcast on it. When you talk about 𝘠𝗏, that 𝘠𝗏, I've looked at those equations many times over my career and lactation and even finishing hogs. And the whole discussion around potassium and chloride, I think, is intriguing as well, because some of us had hypothesized a few years back, like Wayne Cast and others, that maybe there was a potassium shortage that we were seeing when we take soybean meal out of the diet and add in synthetics and finishing that influences the feed efficiency and some of those numbers. And so it's interesting, you know, it still raises that question, and there's not a lot of work that supported that, but yet your work is telling us there's still something there. So maybe the ratios that were investigated weren't quite where they needed to be, or something of that nature. So
well, and yeah, and I think that you're bringing up a very interesting in the longer term. Let me go back in the memory cells. You mentioned, you know, Wayne Cast and But I'll go back to even 𝘠𝘰𝘭𝘵. It was an Iowa State faculty member, and I think you would know Dwayne, and he did some work. I don't remember the dates, but this was back in the late 70s, early 80s, and looking at potassium and lysine use. And so the efficiency of lysine use, and there's, I think, physiological renal metabolism pathways that would kind of justify that there's something there. And that's been a long-term interest. That's why I've kept an interest in this area of how potassium might affect lysine degradation, acid-base balance affecting lysine degradation. And I think we have some evidence that that probably occurs in the kidney. But being able to capture that into a practical, let's make the pigs grow faster type of scenario, we've tried, and we've not been able to quite do that with the 𝘠𝘰𝘭𝘷𝘦, sodium potassium chloride, or different equations that you want to use for that. And I think part of that is maybe kind of a lack of understanding of how the cation-anion balance may be affecting renal metabolism. And so we've dove into that a bit. And I think the acid-base balance under those conditions and what you do with potassium may alter how the kidneys even metabolize lysine. Most of the time we think about lysine being degraded in the liver. Under an acid-base status, I think there's evidence, now not strong evidence from a production standpoint, and how do we capture that in the diet of production animals, but Wayne's right, if you drop use the crystalline amino acids, drop soybean meal out of the diet, you alter the potassium requirement. And with respect for the NRC, the potassium requirement in NRC is probably not correct. I think it was based largely at 0.26%, I think is the number. Potassium in the diet is the requirement. That work was actually done in the 1940s. Here at the University of Wisconsin by my predecessor, Bob Grummer and Gus Bostad. And I think in the 1940s, the pigs were not growing as fast, and they probably did not require that much potassium in the diet. Now we have pigs that are growing much faster than that. And I think the potassium requirement, if you tried to identify a minimum requirement, probably is around 0.5%. Corn soy diets, now that's an estimate based on some of the work that we've done. So I'm not just making that or pulling that number out of the air, but the corn soy diet, typical diet, might contain 0.7, 0.8% potassium. You start using synthetic amino acids in the diet, dropping soybean meal down, that potassium level begins to drop around that range. And we have done experiments now trying to supplement potassium back into the diet under those conditions, and we can get a little bit of a boost in growth. Have we ever been able to document that enough that would convince the Wayne cast of the world? We'll pick on Wayne a little bit. He's a good friend. Can we convince him that that would be something that should be used on a routine basis in the diet? 𝘱𝘵𝘁 at University of Illinois, if he did work with amino acids, he would always add sodium bicarb. This might be work with rats or with broilers. Or with pigs, he would add sodium bicarb back into the diet to buffer the amino acids that were provided. I'm not aware that he's at data that would show kind of a cost benefit and a definite positive effect, but that would be one thing that he would always include in a lot of the formulations, especially if they have a lot of synthetic amino acids in the diet. That's some evidence. We add a little bit of potassium carbonate in the diet or potassium bicarb in the diet, we could improve growth if there's a lot of crystalline amino acids. But then that becomes an economic question. How far do you drop the soybean meal? And right now with those prices and how that's changed over the last year, okay, the guys out in the real world that are dealing with that, good luck, okay? I don't see how you keep up with it. Long-term contracts is maybe the best way that you can survive in this climate. Yeah. It's a problem.
Yes, absolutely. So I think these are some good conversations and certainly ones that need to continue to happen as we continue to deal with pricing and ingredients and availability for sure. But as I kind of see, unfortunately, our time is wrapping up. If you wouldn't mind giving our audience just a little bit of a recap of a couple of key points that you think would be useful for them to take back to their production systems, businesses, et cetera, I think that would be very helpful.
Yeah, I think a key point, and I would direct this mainly to my colleagues, the nutritionists, okay, to say that we cannot solve all the problems by over fortifying the diets. It would be nice if we could do that, but too often we add things to the diet, we continue to add, and we never think about, is that really still necessary? So be, certainly critical. Another one of my colleagues used to make the comment that he would not add anything into the diet that he could not economically justify. And that's maybe a pretty good piece of advice to think about as you're adding things into the diet. Are you confident that you have economic justification that that ingredient is doing what you think it's doing? And for the people that are selling the ingredients, I think most of the ones I know in that industry, they want to make sure that their products are being used correctly. And if they're in business, they're not necessarily promoting over supplementation. We need to work together in the industry and make sure that we're efficient with the nutrients that we use, that we're not overusing those. I think as an industry, we're going to be constantly scrutinized by the consumer of the efficiency with which we use nutrients. So I think we need to think in those terms, not, well, we're going to just solve this problem and throw a little bit more in the diet. The phosphorus story that we talked about with the being able to assess the phosphorus status on a herd-wide basis, those kind of tools I think could be very useful for us into the future.
Very good. Well, as we wrap up, we always do ask our speakers a couple of questions. The first one we like to ask is, do you have a swine resource that you would recommend to the audience?
A swine resource?
Yes.
Besides 𝘬𝘬𝘵?
Besides 𝘬𝘬𝘵, yes.
Okay. Okay, we've used his name a couple of times today. Wayne may be listening in.
Yes.
Okay. Besides that, yeah, it's tough. I mean, we've had discussions among the North Central Regional Committee of Swine Nutrition. We talked recently about the Swine Nutrition textbook that's out there. And it's a reference book. It goes into more detail, but Austin Lewis, that book originally started with that committee with 𝘴𝘰𝘭𝘕 at Michigan State. And then the second edition came out, and Austin Lewis and Lee Southern, edited that. It's probably a little bit outdated and needs to be updated. But as a reference text, I just say there's not good reference texts that are out there that might be something. I think I've got one on the shelf back here, but to pull off the shelf and look up and dig in, that probably needs to be updated. So those are efforts that we need to put into an incentive for people to do that. And people listening in can probably be that. The podcast and the way we communicate in the industry has certainly changed. It's changed dramatically over the last 2 years with COVID and how we communicate with each other. So maybe that resource is more of a network, and what you and Marcio are doing with the podcast is being able to communicate information. Anymore in class, we don't have textbook. Students are looking things up on their computer and they have answers to the question before I can complete the question. So, and they're finding information, and the internet and that type of information is unbelievable. With the information that you find, having time to look for that, especially for those guys like the 𝘬𝘬𝘵 that are driving down the road, since he's listened to these only while he's driving, so keeps him from going to sleep. Maybe if he's listening to my lecture, he may be dozing off. Wake up, Wayne, and keep it between the ditches, okay?
Absolutely. Well, that's perfect. And I think you're absolutely right. There are definitely a lot of resources that are available. And I still occasionally pull a book off the shelf because it's all condensed and it's right there. But other times it's a quick search online to see what might be new that I haven't had a chance to get updated in books yet. So how about something that maybe isn't swine related? Are there any good books that you're reading currently or have read that you would recommend to the audience?
The book that I probably would read, the only other book that I would not read very much is not let's say a research book or a journal article or something like that. It's actually the Bible. And, from my perspective, I gain a lot of insight and a lot of peace And understanding now from that, especially if you look at the world around us and what we're confronted with, and it points to something that's bigger and more in control than we can ever be. And so that's where I have my hope, my faith, and my trust is, what can I learn about God and how God's love for us and his forgiveness and his grace, even when we mess up, and we all do that. And the Bible gives me that kind of reassurance, and I need that reminder on a very regular basis. So I'd encourage people to dig into that resource a bit, try to understand that. It's almost as complicated as acid-base balance, maybe a little bit more so, but dig into it, try to understand that, and get input from people on that as well.
Perfect.
Pay attention to the spiritual side of your life, not just the economic side of your life or the stress side of your life. There can be a balance that comes from that.
Mm-hmm. Yeah, that's very good. Finding balance in life is so important.
Right.
So the last question I have for you, Tom, really evolves around if you can envision somebody in your mind that you have identified as successful in their career. And again, success looks different to many different people. So however you want to define it in your mind, what do you think was a characteristic or is a characteristic of that individual that has allowed them to become successful?
Yeah, you didn't give me enough time to think about that one. I do think, probably the person that came to my mind just as you were asking that question was actually my father. And don't know, not to get into too much of the family background and this sort of thing, but kind of grew up on a small farm, and we didn't have much. And my father never finished the 7th grade. Kind of came up during the Depression and had to drop out. But the thing that he always instilled into me was actually a contentment. Regardless of the circumstances that he was in, he found a source of contentment in his life, and that allowed him to bear up under a lot of different circumstances that we went through. And so if you have something that can bring about that contentment, where it gives you that inner peace. And I think growing up as a family, and maybe some of the listeners online would recognize that they have 2 younger brothers that have PhDs in Swine Nutrition, and we have an older brother, had an older sister as well. So that was a family. So growing up in the family and having confidence and assurance of a family around you that would love and accept you regardless of the circumstances, regardless of what events happen, that contentment, and I think our father and mother both, instilled that in us. And those traits go well beyond what we can do that would bring other measures of success. It's that inner peace that will make a difference, that contributes, allows people to be successful in their careers, wherever they find themselves.
Yeah, that's a really interesting insight. I think that's a good one to consider for sure. Very good. Well, thank you, Tom, for your time today. We greatly appreciate you spending time and helping us understand a little bit more about calcium and phosphorus and some of the challenges that we're currently seeing, and giving us new ways to maybe look at some old problems, if you will.
Sure.
So again, for our audience, this is Dr. Tom Crenshaw from the University of Wisconsin. Thank you, Tom.
Thanks, Laura. Just a pleasure to be here, and thanks for the audience, and keep it between the ditches for those out in the real world.
Absolutely. Thank you.
All right.
Imagine if, with a few key concepts, you could have the potential to create a massive positive impact by bringing from hundreds of thousands to millions of dollars for swine producers. Join us on this small group and go to the next level of swine nutrition on this 7-week-long elite online training in applied swine nutrition and feeding by myself and my world-class invited speakers. Additionally, you enjoy an exclusive community to exchange ideas. Go now to www.𝘰𝘗𝑠winenutritionist.com.